Hello everyone, let us solve this sample problem related to adding perpendicular vectors. Kyle is flying a plane due west at 225 kilometers per hour as the wind carries it due north at 55 kilometers per hour. We need to find the magnitude and the direction of the resultant velocity. So resultant means I need to add these two vectors. If we try and sketch these two vectors, I have a vector of magnitude 225 kilometers per hour acting to the west, okay, and a smaller vector toward the north, which is the wind, as if the plane is flying toward the west and the plane is trying to shift, the wind is shifting the plane toward the north. The velocity of the wind is 55 kilometers per hour north. I need to find the resultant. Now, using our sketching or graphing skills, we know that the resultant will be from the first tail to the last tip. But actually, I'm interested in solving this problem algebraically. As you can see, the resultant here is just a hypotenuse of a right angle triangle. So the first step will be to find the magnitude. So to find the magnitude, I will simply apply the Pythagorean theorem. I will say that r squared is equal to 55 squared plus 225 squared. Simply, r will be radical 55 squared plus 225 squared. Please pause the video and find the answer of this equation. I will get that the resultant is around 231.62 kilometers per hour. So this side of the triangle will be around 231.62, and the unit for velocity here is kilometer per hour. Now, what about the direction? How can I find the direction exactly of this vector? To find the direction, I need to check the angle the vector makes, this angle. We can use our trigonometric functions in order we find the angle. So I can use tan theta equals opposite over adjacent, or simply we can all the time agree that we will use the y vector, so vector on the y divided by the vector along the x. So here the vector along the y is the north vector, which is 55. Vector along the x is the 225 degrees. Now, theta will be simply, I'll continue here, theta will be tan inverse 55 over 225. Notice here that your calculators must be set into degrees, not radians. You will do on the calculator shift tan, open brackets, 55 divided by 225. You will get here the angle, which is around 13.74 degrees. So this angle here at the tail of R, it's 13.74 degrees. We learned before how to describe this angle. This angle is touching or closer to the west direction and toward the north. So it is north of west. Let us agree now that all the time I like to describe the vector from the positive x-axis or from the east. To fully describe the vector, we will add another step. Let us sketch the coordinates here. This is the east, or let me say the positive x-axis. This is the negative x-axis. And my vector lays somewhere here. This is vector r, closer to the west, right? 13.74 degrees. We like all the time, girls, to find the angle from positive x-axis or from the east till the vector, this one, theta. So the last step will be to find theta from positive x-axis. So this is just to this is to make sure that we assign the direction in a very clear way. I will apply a rule that simply says if you are in quadrant 1, then use theta, you got it from the tan. If you are in quadrant 2, you will be using 180 minus the absolute value of theta. If you are in quadrant 3, you will be using 180 plus the absolute value of theta. If the vector is in quadrant 4, you will be using 360 minus the absolute value of theta. As you can see clearly, my vector lays in quadrant 2. Or simply, we can know this here from the directions of the vectors. I have a west and a north vector. So if you check the quadrant west and north, here is the west, here is the north, so the vector must be in the second quadrant. So what will I do to find theta from the positive x-axis, the red theta here on the sketch? I will be applying this rule, which I like to call the quadrant rule, and I will say 180 minus theta that I got from the tan, theta inside the triangle, 13.74 degrees, and you will get the angle directly as 166.3 degrees from east or from the positive x-axis. We can stop here. In some books they stop here at this point, but we can also, to make the direction super clear, go and all the time describe it from the positive x-axis, and this is the way that we will be working together, inshallah.